The night sky recently put on a breathtaking show for people in the UK. Stargazers were treated to a rare and mesmerizing display that left many in awe. The Northern Lights, also known as the Aurora Borealis, illuminated the darkness with vibrant hues. These natural light displays are caused by particles from the sun colliding with the Earth's atmosphere. This stunning display was visible across the northern parts of the country. From the Highlands of Scotland to the rural areas of Northern Ireland, the sky was painted with shades of green, pink and purple. People in Scotland, Northern Ireland and even parts of England were treated to this celestial spectacle. It was a sight that many will remember for years to come. Clear, dark skies away from city lights provided the best views. In these areas, the lack of light pollution allowed the Northern Lights to shine in all their glory. Many flocked to areas like the Shetland Islands, known for minimal light pollution. These islands are a popular destination for those hoping to catch a glimpse of the Aurora Borealis. These remote islands offered unobstructed views of the dancing lights. The experience of seeing the Northern Lights in such a pristine environment is truly unforgettable. Social media buzzed with photos and videos capturing the magic. Enthusiasts and casual observers alike shared their experiences, spreading the wonder of the Northern Lights far and wide. The Northern Lights, usually seen in higher latitudes, made a rare appearance further south. This unexpected event allowed more people than usual to witness the phenomenon. This unusual occurrence was due to a powerful geomagnetic storm, a disturbance in Earth's magnetic field. Such storms can enhance the visibility of the Northern Lights, making them visible in areas where they're rarely seen. The event brought joy and excitement to many as communities gathered to witness the celestial show. It was a night of wonder and amazement, a reminder of the beauty and mystery of our universe. The UK wasn't the only place fortunate enough to witness this celestial display. The Northern Lights, fueled by the same geomagnetic storm, also graced the skies of North America. Across Canada and Alaska, the aurora painted the night with vibrant colors. Even some northern states in the US, like Montana and Wisconsin, had a chance to see a faint glow. The Southern Hemisphere wasn't left out of this celestial show. The Aurora Australis, the southern counterpart to the Northern Lights, made an appearance as well. New Zealand's South Island, known for its dark skies, offered potential glimpses of this southern spectacle. The auroras, both north and south, served as a reminder of the interconnectedness of our planet and the power of solar activity. What causes this mesmerizing display of lights in the sky? The Northern Lights, or Aurora Borealis, have fascinated humans for centuries, inspiring countless myths and legends, but the true explanation is even more incredible. The answer lies in space, specifically our sun. Our sun is not just a source of light and heat, it is a dynamic and powerful star that influences the entire solar system. The sun constantly emits a stream of charged particles known as the solar wind. This solar wind is a flow of charged particles, primarily electrons and protons, that escape the sun's gravity due to its high energy. During a coronal mass ejection, the sun releases a sudden intense burst of these particles. These ejections can release billions of tons of solar material into space, traveling at millions of miles per hour. These particles travel through space and can interact with Earth's magnetic field. The journey from the sun to Earth takes about 3 days, depending on the speed of the solar wind. This interaction causes a geomagnetic storm. These storms can affect satellite operations, GPS systems, and even power grids on Earth. Earth's magnetic field acts as a shield, protecting us from the full brunt of the solar wind. It deflects most of the charged particles, preventing them from reaching the surface. However, during a coronal mass ejection, the surge of charged particles can breach this shield. When this happens, the particles are funneled towards the polar regions by Earth's magnetic field lines. These particles then collide with atoms in Earth's atmosphere, exciting them. This collision primarily involves oxygen and nitrogen atoms, which get energized and move to a higher energy state. When these excited atoms return to their normal state, they release energy in the form of light, creating the beautiful aurora. The colors of the aurora depend on the type of gas and its altitude, with green and red from oxygen and blue and purple from nitrogen. The colors of the aurora are a direct result of the types of atoms involved in these collisions. Oxygen, the most abundant gas in Earth's upper atmosphere, plays a significant role. When excited, oxygen atoms emit green light, the most common color observed in auroras. At higher altitudes, oxygen can also produce red light. Nitrogen, another abundant gas, contributes to the auroral palette. Excited nitrogen molecules emit blue light, while nitrogen ions create beautiful purple hues. The blend of these colors, along with variations in altitude and intensity, creates the mesmerizing dance of light we call the aurora. The sun's activity isn't constant, it goes through cycles approximately 11 years long, with periods of high and low activity. Solar maximum marks the period of greatest solar activity. During this time, the sun experiences more sunspots, solar flares, and CMEs. These events increase the frequency and intensity of geomagnetic storms, making auroral displays more likely. We are currently approaching the next solar maximum, which is predicted to occur around 2025. This means we can expect more frequent and intense auroral displays in the coming years. Scientists closely monitor solar activity to predict these events and understand their potential impact on Earth. While auroras are a beautiful consequence of geomagnetic storms, these storms can also have less desirable effects. The same charged particles that create the auroras can interfere with technology. Power grids, satellites, and communication systems are all vulnerable to these disturbances. In extreme cases, geomagnetic storms can cause power outages, disrupt GPS signals, and damage sensitive electronics. Scientists and engineers are constantly working to improve our understanding of space weather and develop ways to mitigate the risks posed by geomagnetic storms. Early warning systems allow us to prepare for these events and minimize their impact on our technology-dependent world. The Northern Lights, a celestial ballet of light, serve as a stunning reminder of the power and beauty of the universe. These mesmerizing displays, also known as the Aurora Borealis in the Northern Hemisphere and the Aurora Australis in the Southern Hemisphere, paint the night sky with vibrant colors and patterns that seem almost otherworldly. This natural phenomenon, visible in both hemispheres, captures our imagination and sparks our curiosity. The lights are not just a visual spectacle. They are a gateway to understanding the complex interactions between the sun and our planet. The charged particles from the sun collide with Earth's magnetic field, creating these stunning light displays. Understanding the science behind the aurora deepens our appreciation for this spectacle. Scientists and researchers dedicate their lives to studying these phenomena, using advanced technology and observatories to unravel the mysteries of the auroras. Their work helps us comprehend the broader implications of solar activity on our planet. From the sun's activity to the interactions within Earth's atmosphere, the aurora is a testament to the interconnectedness of our solar system. Solar flares and eruptions send waves of energy across space, which then interact with Earth's magnetic field, creating these awe-inspiring light shows. As we approach the next solar maximum, let us marvel at the beauty of the auroras, while also acknowledging the importance of understanding and preparing for the potential impacts of space weather. Increased solar activity can affect satellite communications, power grids, and even climate patterns on Earth. The Northern Lights, a celestial dance of light and energy, remind us of the wonders that lie beyond our planet and the importance of continued scientific exploration. They serve as a bridge between art and science, inspiring both awe and a quest for knowledge. As we gaze upon these luminous displays, we are reminded of the vastness of the universe and our place within it.